In this lecture, we will discuss source transformation in AC circuits. From DC circuits, we know that for source transformation, we can convert any any current source in parallel with a resistor to a voltage source in series with the resistor, and any voltage source in series with the resistor to a parallel resistor with a current source. The same rules uh, apply to AC circuits. So if we have an AC voltage source in phasor Vs with which is in series with an impedance Z sub S, it can be converted to a current source, AC current source, in parallel with the same impedance. Okay, these two circuits are equivalent. What is the ZS? Of course, is same for both equivalent, but what about VS and IS? There is a relationship between VS and IS. VS is equal to Z sub S IS, and let me just write it below the figure. Vs is equal to Zs Is, and Is is equal to V sub S over Z sub S. All of these values are in phasor. Let's see one example. Let's say we want to calculate Vx, which is phasor, in the following circuit using source transformation. Here is the circuit. We have a voltage source in phasor. It's 20 with the angle of negative 90-degree volt. We have 5 ohm resistor, 5 ohms resistor. We have 3 ohms resistor, an inductor with a value of J 4 ohms, then another 4 ohm resistor, a capacitor with a value of negative J 13 ohms, and a resistor with value 10 ohms. The voltage across 10 ohms resistor is Vx, and we are supposed to find it using source transformation. Of course, we can solve it with a mesh analysis. We have two meshes, but the problem wants us to do it specifically with source transformation. So let's do that. In order to solve this problem, consider first we consider these voltage source and resistor and convert it to uh, current source and resistor. Okay, so the new value of the current source will be equal to 20 with the angle of negative 90 over 5, which equals 4 with the angle of negative 90, or we can write it in the form of negative j4 if we need it in rectangular format. So let's redraw the circuit. This time the circuit has a current source instead of a voltage source and a resistor. So this part, we change this part to this part, and the rest of the circuit is same. Okay, the rest of the circuit is same. So let's just draw the rest of the circuit. Okay, the values are 4, negative j13, 10, 3, j4, 5, and the new value for is equal to negative j4. Now in the next stage we see that this part of the circuit is in parallel format. So the 5 ohm resistor is in parallel with 3 ohm and J4. So we call it Z1. The Z1 is 5 ohm in parallel with 3 plus J4. Z1 equals to 5 times 3 plus j4 over 5 plus 3 plus j4 is equal to 2.5 plus j 125 ohms. Okay, so equivalent impedance for this green area is like this impedance. Of course, this one is the resistor and this one is inductor because it's a positive. Okay, so let's redraw the circuit. We will have this current source in parallel with the new elements in inductor and resistor. Resistor is 2.5, inductor is 1j25, and we have 4 ohm resistor here, negative j13 ohm capacitor, and 10 ohm resistors, and here is Vx. Okay, now again, because we want to do it with source transformation, and we again transform this part to voltage source. We transform this part to voltage source, we will have Vs equals to Is times Z1, which is equal to negative j4 times 2.5 plus j 1.25. Vs is equal to 5 minus j 10. Okay, so we redraw the circuit. The converted part is a voltage source, a new voltage source with the same impedance. The impedance was here, is here. So a resistor and inductor. The value of the resistor is 2.5. The value of inductor is J125. The value of voltage source is 5 minus J10 as we calculated here. And the rest of the circuit is same. We have 4 ohm resistor, negative J13 ohm capacitor, and 10 ohm resistor. And we want to find Vx. Okay, we converted this circuit, okay, which has a parallel and serial elements, to the simplest possible form. In order to find Vx, the only thing we need to do is writing a simple voltage division. Voltage division. Vx is equal to 10 over total impedances 2.5 plus J 1.25 plus 4 minus J 13 plus 10 times Vs, which is 5 minus J 10. If we calculate this number, Vx will be equal to 5.519, the angle of negative 28 degree volt. So this is a result. Okay, this is the Vx. In order to confirm or evaluate this answer, I recommend you to solve this circuit with like node analysis or mesh analysis and find Vx and confirm like this result to make sure that this result is correct. So it's a kind of practice. You can solve the same circuit in a different way using different method like mesh analysis and node analysis. It's all I have for this lecture. See you in the next lecture.